Good morning. Today, Unit 2, Fourier Series. Problem is, find the Fourier Series expansion of f of x is equal to pi x 0 less than or equal to x less than or equal to 1 pi into 2 minus x 1 less than or equal to x less than or equal to 2. Hence, find the value of 1 by 1 square, 1 by 3 square, 1 by 5 square, etc. So now we are going to find out the Fourier series. The solution is, by the definition of Fourier series, so formula is f of x is equal to a naught by 2 plus summation n equal to 1 to infinity an cos n pi x plus bn sin n pi x. So what is that? A naught, an, bn are Fourier constants. So now if you look at the interval is like this. You see the interval now? It is from 0 to 1, 1 to 2. So it is given in number. So we are going to find the value for the last number. It is periodicity is 2. So periodicity is 2. So you are going to calculate for L. So 2L equal to 2. Cancel 2 on both sides. You get L equal to 1. So based on this, we are going to look at the formulae. So we will calculate one by one all the constants, and finally we will substitute in this expansion. So what is the value for A naught? Which is 1 by L, 0 to 2L, f of x dx. So what is the value for L we found? It is 1 as per the given the problem. So L is 1, so 2 f of x dx. Now if you look at the problem, you are having two terms, 0 to 1, 1 to 2. So 0 to 1 you are having pi x, and 1 to 2 you are having pi into 2 minus x. So now we are going to split the integral into two parts. So 0 to 1 f of x dx plus 1 to 2 f of x dx. So as per the problem, you know that 0 to 1 is what? Pi x dx, and 1 to 2 we are having pi into 2 minus x dx. So take pi outside, 0 to 1 x dx, and here also you take pi outside, 2 minus x dx. So we know the integration now. Integral x dx is x square by 2, 0 to 1, plus pi. You can take pi common also. Here we are going to integrate x minus x the whole square divided by minus 2. Why minus 2? Because x value only we are getting from negative value here. X is negative here, so we are getting as minus 2. So substitute the limit now, 1 by 2, your lower limit is 0. Here also you substitute the limit. So the upper limit is this term, and your lower limit is minus 2 minus 1 the whole square by minus 2. So this term vanishes, and here you are getting this term also vanishes. So you get pi into 1 by 2. And this value when you calculate, you get minus into minus plus, you get pi by 2. So you get the answer as pi. So A naught value is pi. So we have calculated the first constant A0. Next, we are going to calculate the next constant An. What is the formula? 1 by L 0 to 2L f of x cos n pi x dx. So what will you do? 1 by L value is 1, 0 to 2 f of x cos n pi x dx. So this is the formula. Now we are going to split up into two integrals, 0 to 1 f of x cos n pi x dx plus another term is 1 to 2 f of x cos n pi x dx. Now as per the problem, we know that the value for f of x is pi x cos n pi x dx. Another one is 1 to 2 pi into 2 minus x cos n pi x dx. So now we are going to calculate this by Bernoulli formula. So what is Bernoulli formula? Integral u dv is what? uv u dash v1 plus u double dash v2, etc. So from this, what is, you take pi outside. So u, from the first calculation we will do now, u is x, dv is cos n pi x dx. So we split up into two. So u dash is 1, u double dash is 0. V is sin n pi x by n pi. V1 is minus cos n pi x by, you have to keep on multiply the term in the denominator. So this is what the tree like, you will get it, uv like this, keep on moving. Okay. So similarly, we can calculate for the next one also. U is 2 minus x, dv is what? Cos n pi x dx. So u dash is minus 1, u double dash is 0, v is sin n pi x by n pi, and this is v1 is minus cos n pi x by n square pi square. This is integration. Okay, this is a differentiation, this is integration. So like this, if you do the calculation for both the terms, we will calculate now. So we have started the an only, which is pi already outside. So uv, so x into d uv, what is v here? Sin n pi x by n pi minus 1 into minus cos n pi x by n square pi square. Integral is from 0 to 1 plus, what is the next term? Pi, you take it out, 2 minus x, again once again sin n pi x by n pi, minus 1 minus cos n pi x by n square pi square. The value will be from 1 to 2. So apply the upper limit and lower limit now one by one. So 1 into sin n pi by n pi. Here you get plus cos n pi by n square pi square. Similarly, the next term will be 0. And here also you get cos 0 by n square pi square. This is our first term, plus pi into, substitute the upper limit, sin 2n pi by n pi. You get minus here, cos 2n pi by n square pi square. And substitute the upper limit now. So minus, is it? Minus 2 minus 1 sin n pi by n pi plus minus, is it? Cos n pi divided by n square pi square. So we know the value for sin n pi is 0, so this vanishes. and here also this term vanishes. Here also sin n pi is 0. Sorry, cos 2n pi is 2n pi is 0. So now if you see that these are the terms remaining, these are the term remaining. So from here we know this value is 1 and this value also 1. Okay. So what are the left out terms? 4 term is left out term. So we will bring it here. So which is pi into cos n pi by n square pi square minus 1 by n square pi square. Similarly, you get cos n pi by n square pi square minus 1 by n square pi square. So you'll get it as pi into, what is the value for cos n pi? This one, n square pi square minus 1 by n square pi square plus minus 1 to the power n by n square pi square minus 1 by n square pi square. So throughout you'll get it as 4 times, is it? 4 times, that means minus 4 pi divided by n square pi square. How we are getting is, we are getting the term is minus 1 to the power n minus 1, which is 4 times, okay? Sorry, 2 times of this, because 2 times it is repeated, is it? So 2 times of this. So actually we have to check the value for odd and even, okay? Odd and even. When you are getting odd value, you get the term as what? Minus 1 to the power 1 minus 1, you get the answer to be minus 4. When you substitute for even, you'll get it as, yeah, 0, is it? So you'll get it as 0. So this is valid now. So we are going to calculate as like this, minus 4 by n square pi, n is odd, and 0, n is even. So this is the answer for an. Okay. So next we will calculate bn. What is the value for bn? So bn is same like that, 1 by L, 0 to 2L, f of x sin n pi x dx. Okay. So you know the value for L is 1. Similarly, 0 to 2, f of x sin n pi x dx. So same like that, 0 to 1, f of x sin n pi x dx plus 1 to 2, f of x sin n pi x dx. So both the values for the function f of x given, come on, substitute here, pi x sin n pi x dx plus 1 to 2 pi into 2 minus x sin n pi x dx. So same like that, Bernoulli, u equal to x, dv equal to sin n pi x dx. So what is u dash? Once again 1, u double dash is 0. Here the integration of sine will be cosine minus n pi x by n pi, and v1 is nothing but minus sin n pi x by n square pi square. Come on, put it in the format. So what the formula for Bernoulli is what? U dv is uv minus u dash v1 plus u double dash v2, etc. Okay. So we will calculate this term and this term now. So substitute here, 0, when you substitute, you can automatically change the integration to square bracket, x into minus cos n pi x by n pi minus 1 into minus sin n pi x by n square pi square, where the value is from 0 to 1 plus. So pi is outside, okay, pi is outside. 2 minus x into minus cos n pi x by n pi and minus of minus 1 into minus sin n pi x by n square pi square, where the limit is from 1 to 2. So substitute the values here one by one. So we know that all the sine functions will get cancelled because sine n pi is 0 and sine 2n pi also 0, sine 0 also 0. So all this term vanishes and cos n pi will be minus 1 to the power n and cos 0 will be 1. So if you look at here, this term vanishes and this term vanishes, you get the answer to be 0. Okay, so your Bn value is 0 because we can check the answers here by substituting the values. So now we got all the constants, substitute in your solution. That means definition of Fourier series a0 by 2 plus summation n equal to 1 to, that means we cannot write 1 to infinity because odd to infinity, what is your an value? Minus n square pi cos n pi x. So bring this term to the other side. So take 4 by pi outside, summation n is 1, 3, 5 to infinity cos n pi x by n square. Okay. So we got the solution actually for the first part. Now we have the deduction. We have the deduction part. So how to do the deduction? We are having the midpoint, is it 0 to 1 to 2. So we take the middle point to be the point of continuity. X is equal to 1 is the point of continuity. Okay. So when you substitute x equal to 1, you can look at the question. You are having two terms, pi x and pi into 2 minus x, 0 less than equal to x less than equal to 1, 1 less than equal to x. This is a problem. If you take middle point anywhere, you get the value to be 1 only. If you substitute x equal to 1, you get 1. Here also you can substitute 1. So this is the point of continuity. Substitute x equal to 1 in this above equation. So what do you get? F of 1 is equal to pi by 2 plus, minus, minus 4 by pi, summation n equal to 1, 3, 5, etc. infinity, cos n pi x, that means 1, is it? Divided by n square. So bring this, what is f of 1 actually? Pi. So you are getting f of 1 is pi. So pi is equal to pi by 2. I think what is the value we are getting? Plus, minus 4 by pi. What is that value? Summation 1, 3, 5, etc. infinity cos n pi. Is it? Okay. Now you bring this pi to the other side and you get negative value. Here also you get negative value if you substitute cos n pi. That means n value is 1, is it? So you get cos 180 is minus 1. Cos 3 pi also minus 1. Cos 5 pi also minus 1. So all the negative value you take it out. So you get it as plus 4 by pi. Okay. Summation, this is n square is here. So that means the summation if you expand, you get it as 1 by 3, 1 by 1 square, 1 by 1 square, 1 by 3 square, etc. So this value will become positive. So here you get pi by 2. Here you get 4 by pi. So 1 by 1 square, 1 by 3 square, etc. So bring this term to the other side. So you get it as pi square by 8 is equal to summation n equal to 1, 3, 5, etc. Infinity 1 by n square. So we got the complete solution. Thank you.